Alice in Dataland podcast is a trip through the looking glass into autonomous learning investment strategies. Jeffrey Tarrant is the chairman and founder of Move37. All opinions expressed by Jeff and podcast guests are solely their own opinions and do not reflect the opinion of any firm. This podcast is for informational purposes only and should not be relied upon as a basis for investment decisions. Clients of Move37 may maintain positions in strategies and securities discussed in this podcast.
So welcome to Alice in Dataland, and we're in Switzerland for Alice in Dataland, and I'm Jeff Tarrant, and next to me is one of our advisory board members, Nate Sauder, who I met many years ago. By the way, where are we in Switzerland? Some little town named Champéry, and we're here at a conference, but I thought it was a good opportunity to have our next videocast/podcast with one of our advisory board members. How I met Nate was years back when I had seen the TED Talk given by Jeremy Howard of Analytics, and that was kind of a life-changing TED Talk that I saw that was just looking at when does computer intelligence approach or even cross beyond human intelligence, and I think it was an incredible TED Talk. So what I normally do in those sorts of situations is I'll call up the people who give these talks and want to visit them. Jeremy Howard and that company were out in San Francisco. We're based in New York, and I get out to San Francisco a lot, and I called Jeremy and I said, look, I'd like to come out and meet you, and he says, hey, I'm not there that week, but here's someone you should meet, my right-hand man. And it was Nate, and here's Nate. So welcome, Nate. How are you?
Welcome. Thank you very much for having me. Thank you very much for inviting me to Switzerland, because this is quite an extraordinary setting.
Yeah, isn't it? So, Nate, look, when I first met you, you told me about your background, and it's super fascinating. Would you mind telling our audience a little bit about yourself?
Sure. So I guess my story began when I was like 8 or 9 years old. Obviously, it began a little earlier than that, but nonetheless, sort of conscious story began when I was 8 or 9. My parents decided to homeschool me, so they took me out of school, mostly because I was just rubbish at French, and we were in Montreal. And so I was taught a variety of topics there, mostly like ancient Greek and Latin, and then math. And in those 2 years, we did something like 12 grades. And so when I was 11, we moved to Toronto, and I started at Abelard School, which is a small high school, and U of T. And I was sort of doing mostly math and ancient Greek again. And then I spent 8 years in college, from 11 to 19 at various schools, U of T, UBC, UChicago, and Oxford. So I got the full Anglo-American college experience.
Yeah, wonderful. And when you were at Oxford, and I'd asked you this when we first met, I said normally at Oxford you'll have some sort of fellow or don that you would work with.
Right.
And coincidentally, you had introduced us to Zubin, who has been the subject for our previous videocast, and he's also on our advisory board. Can you talk a little bit about that?
Yeah, absolutely. So I was unbelievably fortunate, right? Because I just sort of signed up to study at Oxford and do some interesting research there in math. And when I got there, I was sort of matched up with a tutor called Zubin Singaporia. And little did I know that Zubin was something of sort of an Oxford savant, sort of a master of everything from mathematics to tennis to hypnosis to various other subjects. And I was only his student for like 3 or 4 months, but probably learned more in those 3 or 4 months than the previous 4 years combined. And we had just an absolutely wonderful time together, and have remained great friends since then. And I'm glad that he works with you. And Zubin is a wonderful guy. I think he was on the previous podcast too.
Absolutely, yeah. So that's where he got to describe homomorphic encryption. Anyway, so tell us a little bit about what you were doing after leaving Oxford. What was next?
Sure, absolutely. So I guess the story started in maybe the spring of 2013 or some such, and a professor at UChicago had asked me and a friend to sort of figure out if you could determine crime from street view images. And we were mostly naive mathematicians, and so we started Googling around for what to see in images. And so we tried convolutional neural networks, which at the time were not nearly as well known as they are today. And, we somehow got it to work. And despite being like total fools, really within a day or two, like, the models were really good. And so we were like, well, this stuff is very powerful. And so spent the summer sort of studying it, went to a conference. And as you said, Jeremy at the time was giving a talk saying, I'm about to start a company that is going to be really the first company to bring machine learning to sort of medical imagery or even medical diagnostics most broadly. And so sort of got started there. Initially, really as like a 3-week intern, and then sort of grew from there to build some of the initial deep learning models. We worked on like wrists and lungs and various other parts of the human body, and ended up being the chief scientist there and sort of leading some of the technical work, and just learned an absolutely enormous amount there.
Well, great. So what broad conclusions do you have from that experience?
Tons, right? It was very early in the sort of history of machine learning. And so like, it's hard to believe now, but, in our C decks, we were like, deep learning is, and explaining it to like people in the Valley, right? And so, let alone anywhere else. And, so learned a ton. Interesting things around the data, right? Because the company had a fair amount of publicity, and so was able to chat with like, the high-level C-level executives at, Mayo Clinic and MD Anderson and whatnot, really from day one. But really being, despite the first to know, they really didn't make much actions for many years, really. And so the company ended up having to commercialize in Australia and China, especially in China, where they're just much more ready to work with data, and sort of move healthcare data from sort of something that's talked about in endless conferences to things that touch real patients. So that would be one. And then two, I think, was like a really interesting thing that like we sort of had this business model in mind to do teleradiology, which is sort of where, you go into the hospital, you get your scans done, those scans are then sent over the internet to a different group of radiologists in a remote location. They do their reading and then they send back the information. So you can think of it as sort of like a human radiology API. And didn't end up pursuing that because it was just sort of challenging to figure out how to work with them. But I think one of the things that was sort of most thought-provoking about that exercise in retrospect was that, the internet was this giant innovation on the distribution end.
Yeah.
Machine learning is a giant innovation on the sort of like processing end, right? Processing, in a factory, processing in a hospital, processing anywhere else. And data and distribution are always really hard. And so something that, I believe more and more strongly is that like in 10 years, we may very well look back as like at private equity being the sort of vehicle for bringing, machine learning into the real world.
Yeah.
And the ability to sort of buy data and buy distribution and then bring in really smart people to turn those into really wonderful things, I think will turn out to be a very big story.
Yeah, and the private equity component you're talking about is because it takes a long term to kind of develop these things and to develop a market, right? Is that what you're saying?
Yeah, exactly. And then also like just everyone is very skittish about their data these days, and so you end up just sort of like really having to like barnstorm the globe asking people for images, right? Which is sort of a strange activity.
Right.
And I think that the sort of like data is gold story has sort of been told broadly.
Yes.
And people have sort of gotten on board with that, but it's also led to like a lot of skittishness around sharing data.
Right.
And then I'd say that's sort of like on the train the model, and then in the sort of like operationalize and deploy the model, then you need this sort of like institutional willingness to do it, right? And like, one of my partners worked on the AWS supply chain, and figuring out how to automate that and digitize it, and then train the models to make all the allocation decisions. And it requires a lot of organizational buy-in to deploy. And so that's why I think that it might turn out, might not, that instead of SaaS, it's more of a sort of private equity model for like how this stuff really gets deployed at enormous scale in the real world.
Yeah. So when we first met, I remember asking you, because I kind of grew up in that part of the world, Northern California, and I asked, where do you live? And I expected an answer of like Noe Valley or the Marina or Sausalito or whatever. And your answer was quite different than that. You said, I live in a science or scientist house.
Correct.
Can you tell us about that?
Sure. So I started Topos with two friends of mine. One's Seb Zaney and the other's Laura Deming. And Seb is a sort of category theorist, and Laura is sort of one of the more distinguished anti-aging venture capitalists, and actually started her venture firm at like 16. And basically we got together and we brought together like a dozen scientists from various different areas, basically all animated by the same principle, which is that like you usually learning sort of falls off a cliff post-college.
Yeah.
And we sort of wanted to sustain lifelong learning. Yeah. And so, as a result, it sort of grew a lot more than sort of thought it would. It was initially just like, well, we'll have like 12 people in a house and interesting things will happen. And in the end, like a lot of interesting interdisciplinary projects have been pursued. I think the Canton is going now. But, yeah.
It's funny, our interviews, the bells always start ringing.
Exactly.
Even with Zoom, go ahead.
So yeah, I mean, that was it. And then now we, actually, interestingly enough, like we're working with Tyler Cohen, who's like one of the leading sort of economists around, to sort of help build a structure where we like sort of fund various fellows from different disciplines to live together and work on interesting things.
Yeah.
And then I think in general, this is sort of like a hunch. It's not something like super formal. Is that sort of like online learning, like MOOCs and things like that, have really taken off, but they sort of lack a social component. Yeah. And when people think about like, why did I love going to Yale, say, they usually talk about like the 100 people they lived with.
Yes. And
so we've seen WeWork sort of explode on like the office co-working space.
Yeah.
And I think there's probably something similar, but in learning, where you have like sort of a series of networked homes, maybe structured as a REIT or whatever the financial details are. But the general principle are that you sort of have like these network buildings where interesting people from all around the world come together to learn what they're supposed to learn. Right. And they sort of like harvest all the information that's being learned online.
Yeah.
And so I wouldn't be surprised if in like 10 years, like we think of the next great college as sort of being something like a WeWork style.
Interesting. Okay. So, and also, not too dissimilar from universities. There's kind of even a screening process to get into some of these places, right?
Yeah, exactly. Sort of like try to keep it very informal because it's a little rough to be judging your roommate.
Yeah.
But in general, we get a lot of referrals from various people, and then we sort of like have a series of interviews, and I've cooked now a Sunday dinner 85 times in a row, where we like bring together like a dozen to 24 people from around various fields, and so we sort of draw from that group, and that's sort of what we're up to.
Yeah, wonderful. So, by the way, I saw the Topos logo. It's really fascinating. So, do you want to talk about that?
Sure. Yeah. So it comes from two places, right? So it was one of these things where you start a venture with someone, and strangely enough, you come up with the exact same name for two different reasons. And so, Topos is sort of a field of category theory that's sort of particularly abstract, and hence of interest to my partner Seb. And then topos is also the sort of the Greek word for place. And so that was sort of the origins of the term, and hence why it's sort of in Greek letters, with the sort of commutative category theoretic diagram around it.
Yeah,
that's the topos diagram.
Beautiful. So then let's continue on. So beyond analytics, then you went off and did something very entrepreneurial. You talked about your partner.
Yep.
And let's talk a little bit about that, and then go on and talk about kind of the future of artificial intelligence and machine learning and where you see things going.
Sure.
Yeah.
So sort of left Analytic in June of 2016. Then that summer, actually went to the party that at Greg Brockman's house, which is the guy who started OpenAI. And there I met a college friend of mine, Charles Carey. So he wasn't really a college friend because like we didn't know each other, but we'd had all the same advisors and we'd actually worked under the exact same professor. So it's one of these things where we met and we were like, well, we actually have done all these things together. And so we started by, his expertise was in building distributed systems. So he's helped build some of the largest databases at AWS, and then he also automated their supply chain, which is sort of like a very capital-intensive endeavor. And so we started by working on a bunch of interesting distributed reinforcement learning projects, and reinforcement learning at that time had just sort of started taking off with the Atari and AlphaGo results. And so we sort of in a week, we built a library for training distributed agents. And I think there's a lot of merits to distributed reinforcement learning as it's being proven out. The basic idea is like, instead of having a single learner, you can have like thousands of learners that are sort of like collectively sharing their knowledge. But instead of like sort of two students getting together and cribbing notes, they're sharing data at like gigabits per second. So one of these like, well, this is very unfair. And so we built that together, and then we were like, well, reinforcement learning exists to optimize, individual numbers, right? And sort of play games to optimize individual numbers. And so we're like, where in the world are there interesting individual numbers to optimize? What is an interesting number of such a sort? And so we started thinking around, and photosynthesis came to mind. It's sort of this phenomenon that generates like 130 terawatts of energy, around the world, which is around like 30 times what humanity uses, or maybe 5 times now. Humanity's graph is growing quickly. And so we basically built a machine that measures the photosynthetic efficiency of every cell in every plant every 30 seconds or so, and then controls the weather via reinforcement learning algorithms to get those plants growing as quickly as possible. And so this we commercialize it in a few different ways, but that's sort of like what our current venture is.
Yeah, wonderful. So I don't know if you guys are hearing the background noises here, but we're interviewing outside, and there's the conference that we're part of. There's some noises in the front, and there's some noises. I think they're moving some things behind us in the back. But anyway, I think it's not going to distract you from understanding the message of this brilliant gentleman. So let's continue on. Great history. What's next?
So for me personally, I sort of just gotta keep cranking. But I think there's a bunch of like really interesting things going on in the world of machine learning. I think one that is sort of like gaining attention but still has a lot to go is infrastructure around very quickly labeling, right? Because I think one thing that people have discovered is that they build these data warehouses, data lakes, data stores, whatever data, and then the question is like, what the heck is in the data?
Right.
And so that's why I think you find consistently that like valuable machine learning comes from valuable labels more so than valuable data. And so infrastructure for labeling is a huge story, and I think there are like a few VC-backed companies that are pursuing it. But in general, like I think MTurk is sort of sitting there as like an Amazon resource. They could very well be its like 4th giant business. But there's just like a lot of human unreliability. But I think if you write really interesting software on top of that unreliability to reconcile things sort of in a more industrial way, then there's a tremendous amount of value to be captured there. And in general, I found that like when you talk to the very best machine learning teams, they often have like the best strategies around labeling. So I know that Analytic, like really most of our core IP was not around like sort of the models we trained; it was around the labeling machines that we built.
Yeah.
And so that's sort of the background there.
Yeah. Okay. Well, I can just say I'm really proud to have you involved with Move 37, and been a great help to us so far. And I think your career is going to be kind of on a exponential trajectory.
It's very kind of you, Jeff.
I like to be a part of that, and I am a big supporter and want to continue to be. And thank you for supporting us. Any final comments that you'd like to chat about?
One thing I'd just say that I've found really inspirational about like sort of hanging out with you, Jeff, is that I feel like a lot of folks sort of become like more jaded over time and like cease getting excited about new things. And I feel like there's so much to be admired in how like you very quickly learn new things and very quickly adopt new things. And I feel like I've actually just found it even myself that I like sort of miss my like 19-year-old self who was just sort of playing around with deep learning models and going like, this is unbelievably powerful, right? I wouldn't say beyond like, I think that there are absolutely amazing things to be done in machine learning and molecular biology, because I think that in a decade, we'll discover that molecular biology has data sets far vaster than even like web scale data. And so like it's definitely still have some amount of technical excitement and like sort of driving forward, but I really say like deeply admire that like
I appreciate that. Thank you. I believe in the old adage of live and learn, and actually it's kind of literal, right? Live and learn, and if you're not learning, maybe you're not living. So it's kind of like this virtuous circle. Right? Yeah. Okay. All right. Well, thank you so much for joining us, and let's go enjoy the weather.
Absolutely. Thank you very much, Jeff. Let's get a tan.
Yeah.
Thank you for listening to Alice in Dataland. For show notes and more information on Alice and Move 37, please visit our website at www.mov37.com.